Hello and good morning, good afternoon, good evening, wherever you are. I'm Nikki Parpovich-Steifel with Esri, and we are here for the webinar for using generative AI with Site to Do Business. We will just hold on a few minutes here and wait for folks to join in. We'll be back in 1 minute. Great, thanks so much for joining us today. I am Nikki Parpovich-Steifel, the Industry Manager of Consumer Goods and Services at Esri. Welcome to today's webinar entitled Using Generative AI with Site to Do Business to find new insights and drive sales. This is sponsored by Esri, and we're happy to share this webinar with everyone in the industry today. Joining us is Helen Thompson. She is the Group Lead of Content and Applied Analytics with Esri. She'll be showing you how new functionality in ArcGIS can provide you with the essential tools you'll need to find new opportunities in your portfolios. Please feel free to ask questions throughout. To do so, feel free to share them in the Q&A function in the interface, and we'll be answering as many as we can at the end of the discussion. If you are experiencing any technical difficulties, let us know through the chat feature to ask for help. The recording and the presentation will be emailed to all registered attendees. Helen, welcome, and thank you so much for joining us today. I'll turn the show over to you.
All right, thanks, Nikki, and yeah, welcome to everybody wherever you are around the world, whatever time zone, whether you're joining us live or watching the recording. I've been honored to work with CCM for over 15 years now, and very passionate about supporting you, but particularly around the second part of this description, which is about creating new insights to drive success and make money. You know, when I think about my role at Esri and strategically leading this relationship between us, you know, I find a lot of people ask me questions about technology. So let's start off and talk about machine learning, artificial intelligence, and where these are going. You know, deep learning is the fundamental building block of artificial intelligence. I talked about this in the Site to Do Business webinar. It's about learning from a large amount of data, typically called large language models, and it recognizes and classifies things. And we're going to do some deep learning. I'm going to show you how you can do both deep learning and machine learning. Machine learning sits on top, and what we do is we improve those models and that learning by training it and improving our training data sets and our experiences. And I'm going to show you how I trained a model to predict the sales for a hospital as an example. So it's looking at the feasibility and the viability of that hospital. It's also about looking at the long-term return on investment. If I build a $30 million hospital of this size with this number of patients and services, how long is it until I get my money back? And so this is about analysis, prediction, and augmentation of our knowledge. AI doesn't give you everything, right? I want everybody to be clear. This is mimicking human intelligence. It's based on what we learn, and AI can be incredibly dumb. It pretends to be smart, pretty much like me, right? But we also adapt, right? It adapts and learns, and the more that you teach it, the better it gets. But artificial intelligence is really about creation and simulation. And I want to show you how you can simulate different scenarios. So as we go through the hospital example, think about it as nothing more than kind of a prototype, an exemplar. an idiomatic example that you can look through, because we're all familiar with this type of scenario. And when we talk about generative AI, there's really 5 principal types. And what I'm going to focus on is analytical AI, that's generating analysis and generating insight as an output of that. An interactive AI, this collaborative tool, which creates new outputs and insights. You're probably familiar with that through the discussions about ChatGPT. That's a text application. I'm going to use Google Bard throughout today, but I use Bing, Chat PDF. I use Best Take, to get great photos. I use Firefly from Adobe. Been using Boomi in some things to simulate my favorite band. And then there's code agents, there's videos, there's lots of different things. And at Esri, we're working on co-pilots. We're prototyping a co-pilot for business analysts, which we'll share in a webinar next year. So let's get started, right, on this journey. I'm using Bard, right? This is Google's AI assistant. And what I basically type into this, and it's a real conversation, and I'll show you it live towards the end, is I said, what factors affect healthcare usage? It came back and identified things like the individual characteristics, the age, gender, socioeconomic status, race and ethnicity, but also the access to care and cultural behaviors. So people's psychographics, people's ability to spend, competition, the locality of the hospital, the type of services that it offers, supply and demand characteristics are all things that we think about. And I can ask Bard to tell me what variables ArcGIS has. How can that help me? Right? And it dives into the information, talks about the fact that we've got place-based data, population, income. It understands about young and people and the elderly, right? It recommends fertility and mortality rates. When we start thinking about service consumptions, availability of insurance, that supply and demand, right? Where do people have chronic conditions? All of these things are exposed through this conversation. And what I'm going to do is I'm going to continually walk through this and expand through what we call feature engineering and prompt engineering. So I want to create a conversation. I want to know how to access the variables, right? So it might be going and finding the data source. It talks about demographics, that you can get them through business analysts, you can get them through the Living Atlas, their layers. It references some of these like age distribution, population density, ethnicity. We know those sources. So you can get data from the CDC, from ACS, from lots of different areas. And we've built these smart agents into business analysts and into ArcGIS. We can be really intelligent about searching for data. So in the documentation that we've built, we've made it more accessible, and these lists of data sets. So not only can you find them, but you can start to introduce concepts. So things like social determinants of health, maps of healthcare facility, prescription drug use, hospital visits. These aren't just categorization of words. These are things that you can use to introduce concepts. So when you search for data in business analysts, because you might want to enrich a site or a location with attributes, or perform spatial analysis like smart map search or color-coded maps, suitability analysis, threshold analysis, that ability to discover the right type of data, the right type of attributes, and know how they relate to each other is really important. And then building visualizations which talk to you and show you the relationships between data sets. We've been building all of this in. So here I am searching for social determinants of health. It comes back with 474 variables associated with that. We can sort them by relevance, and we can sort them by category. I can filter them down, so just find 144 which come through the American Community Survey. You know, that was part of the update that we did in October in the last release. So a lot more data available, and we'll be publishing the next version of ACS in 2024. So those data sets are our starting points, right? They're things that we can discover, but we still don't know about relationships. We don't know how these things come together, right? But I want to discover that. I want to look at this, because at the end, what I want to do is to use these sort of rules that I can start to select a site. And so the end goal of this analysis is to use analytics to find me a result. So this is my BARD conversation. I start off asking what factors are there. Everything that I've just described to you is in this conversation. It's simply type it into a prompt. I can ask about documentation, right? Where can I get it from? Go to blogs, go to other places. Here's my conversation with it about business analysts, right? And then we're going to talk about regression analysis in a little while. I can use this idea of regression analysis and analytics, the correlation and association between data in smart map search. So that idea of the attributes I might use, I got a subset out of BARD, right? Senior population, healthcare usage, working age populations. And so for Dallas-Fort Worth Metro, I've found those different characteristics. I know what the average spend is, and I can see how dynamically I can test these relationships. I can use Smart Map Search to target or understand the dynamics of these individual zip codes. I can use the chart feature in Smart Map Search to see how these relationships are explained. So we can look at regression in this case. So the R-squared value here says that if I look at senior population and the spend on healthcare social assistance, 11% of the ratio of the relationship is explained. So there's not a high determination between those two variables at the level that I've filtered these data sets. But those relationships change, right? And I can look at different factors. So maybe I'm interested in personal care and products and services. Well, does that have a different factor? Well, actually, it explains things even less, right? But in combination, it might have different impacts. So across the whole data set, you might have low relationships, but within individual locations, within individual zip codes, it might explain those relationships more and more. So essentially what I'm doing is I'm learning about the distribution of these data sets because I want to train my model to understand this. I want to see if those factors may be deterministic and dependent in some areas where there's one behavior, and in another area, other factors might contribute to it. So I can use the comparison report. So I've grabbed over 1,000 hospitals here in the Dallas-Fort Worth area. I've generated a 15-minute drive time around them, and I've exported to Excel all of that data. So now I've got a training data set. These are my 4 variables. But for the work that I'm talking about in this webinar, I've trained it on over 4,500 hospitals in the LA Basin area. And I've trained it on 50 plus variables that I've dumped out. But this is to give you an example, a recipe card, if you want, for how we can, or you can use business analysts to understand the data, gather that information, and export it into these training models. So let's go back to the slides and sort of work through this a little more, right? I want to predict hospital usage. I want to see how sales may be related to the demographics, proximity, other areas. And what it tells us is that we have a linkage by using spatial analysis, right? Spatial analysis is about examining locations, the patterns and relationships of those features to gain new insight and knowledge. Regression analysis, that showed in that smart map search, is one of the best ways to do this. And there's multiple forms of regression analysis. And what it's doing is looking at the relationship between one or more variables. And we want a deterministic relationship. And by that, what I'm looking for is to say sales are dependent upon a range of factors or variables. So I want to find the variables, which we call independent variables, that are most influential in determining the sales of at our hospitals, at our stores, at our self-storage locations, whatever that might be. So we're going to use machine learning and a training process to predict them. So all these things we can combine. You've got access to all of these tools. ArcGIS comes ready built with a whole set of classification models, right? Logistics regression. And what that's about is the probability of a binary outcome, right? So in this case, whether a patient may be readmitted to hospital is one example. So we're talking about healthcare usage. You can use logistics regression to basically say, how many times will people visit the hospital, right? How many times will this group of people need to put a product in self-storage, right? So if somebody owns an RV, they might want to store that if they don't have the room at home. If they're they're young people with their first apartment living in multi-family dwellings, they might use it in a different way. But logistic regression is a wonderful tool for these binary outcomes. Think about the idea of, you have a new baby, a new member of the family, right? There's not just one hospital visit. There's not one visit to healthcare. There's multiple visits, right? If you've got an elder member, then there might be additional visits. You can use these types of analysis and these learning algorithms to look at the relationship between variables. Does the availability of employer-provided healthcare affect how people use services and the type of services they use? Random forest is one of my favorites, and we're actually going to use this. What it is an ensemble model. So it creates different scenarios. It'll take a set of attributes and it will randomly distribute them across trees and in different organizations and different hierarchies. And what it does is it tests different scenarios of relationships. If condition A is true, then result B occurs. In result B, if condition C occurs, you have a choice between, the next leaf down, D1 and D2, right? So you can build these hierarchical learning algorithms, and you can do that completely randomly, or you can do it in a consistent way. So what that means is you can build a random forest model of, let's say, consumption of entertainment in a sporting environment that also offers food, right? A sort of Dave and Buster's type environment. And you can build your Dave and Buster's model, make it consistent, and go and run it anywhere in the country. You can make it deterministic in terms of certain characteristics. And so this is a really important kind of concept. It's easy to use. It's supported in a lot of machine learning packages, and we'll show how we can combine that. And then there's things like, lasso regression and ridge and lots of complicated ideas, but there's lots and lots of techniques, as I'll show, to use those. Clustering with things like k-means, it's about saying, how do I find things which are similar? So you can train these agents, you can use these types of analysis to say, well, I've exported all of that hospital information, I've got 4 or 12 attributes, 12 attributes is better, about those 1,000 hospitals. Now cluster them using k-means to identify patterns in that data, subgroups of hospital care. It's an advancement over smart map search, but what it's doing is saying, well, I can find all the places that might be hospitals which are serving an aging population that is also locations where young families are moving in. This is an area of lower income, which has been recently built, because I'm looking at the housing construction age and the size of the household and the income, right? They're the 3 deterministic factors which identify the groups and the subgroups. And so you can do that in a supervised way, an unsupervised way. There's lots of things that we can do. Or tools which build on the work that you already know from being a CCIM. So we implement traditional machine learning, solve a range of problems I just discussed, spatial machine learning, in which we accommodate geography, and we're building the platform out to support all of this. So my example, as I said, 4,000 plus sites in LA. I'm interested in the demographics, service consumption, location access, travel times, the service that are offered, and then other factors which will determine the usage. I'm going to build a gravity model. So I'm going to weight the results and what I'm learning as well. So I'm going to understand the demand by size and distance, by the facility type. They're all going to be included in my model because I'm using spatial artificial intelligence, GOAI is often how we describe this. And I want the attractiveness to be based on a combination of factors like the proximity and the ability to reach it. And we're going to enrich each POI with those characteristics. So I can see the density through this analysis. So I can all start to understand how different types of healthcare facilities might attract you to a location, or might be a factor that repulses, as we talk about in attractiveness and gravity. So it might be a heavy weighted, because in an area like Loma Linda, near to where we live, it's got a high concentration of hospitals. Or in this example, you can see those in LA and up to Beverly Hills, and you can see the areas without hospitals. So there might be ways that we can get access to these. And what we think about from a model perspective is that there's a real case for understanding the factors that influence the outcomes and the degree of their influence. So a great way to think about this is, I want a healthy plant. I want sales. So the dependent variable is the health of a plant. The independent variables that influence it are things like water, light, temperature, and fertilizer. An independent variable is a factor that change the outcome because of the degree of the change, right? So if I overwater a plant, it's probably going to die. If I give it the right amount of water, it's going to grow strongly. I can over and under fertilize. I can make it too hot. I can do all these different factors, right? And they all come together individually, and also they compound. So there's a sweet spot of water, light, temperature, and fertilizer, which will grow a particular response in the plant. They will grow in a particular way. And one of the aims of machine learning is to understand how I can create a consistent plant health, i.e. growth, from adjusting those 4 factors. And sales of anything or usage of anything, outcome, is done in exactly the same way. So what we're aiming to do is to find the factors that can deterministically and predictively identify sales and sales opportunity. So we use a number of techniques. One of the best ones is a correlation matrix. I can see how each one of these variables affect every other variable. In this case, let's look at median household income right in the middle. Despite what most people think, there's not a strong correlation between median household income and spending on insurance. Other factors are much stronger predictors of insurance spend. But insurance spend itself, if you follow the line horizontally, the 5th one down there, it doesn't have a lot of strong correspondence. Insurance spend is often associated with particular zip codes, right? And it's also associated with other healthcare, right? So if you spend a lot on insurance, you might spend on other forms of healthcare. Where we see is strong correlation between things like healthcare workers and long-term insurance, right? That's somewhat logical. Or the age under 19, so young people and healthcare workers. If there's a lot of healthcare workers, there's a lot of young people. Well, that relationship is in one direction. So what it's actually really saying is, if there's a lot of people under 18, you need a lot of healthcare sites and a lot of workers to support them, similarly to people aged 65 and over. But the local bed ratio has strong correspondence to healthcare workers, right? So this is a way of understanding what are those factors. I want to remove median household income. I want to look at the fact that age of its different types might be the primary determinants. I took that model and I ran it through an algorithm that essentially predicts through training what the sales were. This is the distribution. And I predicted 82% of all locations with the registered sales plus or minus 10%. So about 8 attributes, using 8 attributes that I learned through the model by taking 50 attributes and 4,000 plus sites. I can now predict with 8 attributes 80% of the time what the sales are going to be for any location in the LA basin based on a 15-minute drive time. That's a pretty powerful capability because I can just use that repeatedly again and again and again. And yes, there's large variations. I think James shared the difference between a hospital visit and a doctor's visit or an ER visit. And part of it is being able to train it right on those behaviors, train it on usage, identify what variables and what information you have. I don't have individual visitation information in terms of usage of individual services. But what I do have is spending on emergency rooms, dental care, hospital, urgent care, other areas, right? And I can use that as prediction of visitation. I can also do what many healthcare providers do and say, well, at a particular age, so 18 to 25, how many visits of a particular type are people likely to make? And there's information and statistics you can find using AI that describe that type of information. I've worked a lot with drugstores, and we have a model that predicts the number of prescriptions that you're going to have by age, the number of visits to purchase everything from makeup and bandages to, you know, who's likely to eat or purchase the candy at the front of the store. Those are all done historically using rule of thumb. We're using AI to improve that, right? We can now ask the AI tools to generate Python code for it. This is a great starting point for what we want to do. It's not just written Python code, it's written ArcGIS specific Python code. It's loading our Python, ArcPy, it's loading pandas, it's loading this data file, healthcare.data.csv. So I can load that with everything that I want, the location, its attributes that I've built out of the training model, or I want to put into the training model, right? And then I can run these different functions. So I can train it and say, well, maybe in this example, I'm just using a 2-mile ring, right? And so that's the way that I'm going to use this model, and it's going to perform the analysis based on it. And you can take this code and put it immediately to work in ArcGIS. You can learn how to then change the parameters, anything that you want in terms of those parameters in that model. You can use notebooks to do the same thing. So notebooks are a way that you can automate the process. It's a different type of environment, but very similar in it and its concept, right? And what Bard's come down and said, well, here's an example of doing that, and I'll jump to that example here in my my notebook. Oh, okay. Well, I'll say don't restart that. I just halted this process. So in this example, it's restaurant clusters, the one that Bard referenced. And what we want to do is basically go and get a bunch of restaurant data. You can run this live, just as I've done here. And we're going to go through a set of steps. We're going to cluster the restaurants, create zones, and then we're going to prioritize them based on scoring. So just like we saw before, it's generated all the code, and I'm loading these locations. I want to create a map and a histogram of it. And so all this code allows us to then take an XY street address. You can see this has come from Infogroup Data Axle. And then we're running through and performing analysis. So what we're going to do is look at, you know, some data subjects, right? So we're going to establish the employee numbers, right? The sales volume, the score. And so they're all things that we want to come back and understand, right? Understand the quintiles in this case. So getting what we call data engineering, understand the distribution of this data and the associations. Are those in my estimations? Do they fit in some pattern? So then we're going to basically start looking through these in terms of saying, now let me start to color code them by revenue. What are the top 5 restaurants by sales volume? I can train my assistant to do analysis, right? I can think about them by a different form of analysis. What zip codes aggregated up have the most sales? So for that restaurant group that I've selected, let's find those, right? I can create a whole set of rule base now, so I can now start to really work through this data, find the places, bring maps in. But I don't have to do any of this. I could jump right the way through, remove some of these steps, and just go into density clustering. So now what we're going to do is we're going to take all of these locations, and I want to build this and say, let's think about the relationships between these locations and how they might affect each other. So a restaurant might automatically attract other restaurants to be alongside it. Sometimes it can repulse or repel it, right? So we got different models of doing this. You can choose a range of distances around clustering, or you can fix it. This HDB scan, as we call it, is this high-level algorithm that automatically adjusts, and it's the most data-driven model of clustering. So often we get familiar with saying, a 5, 10, 15-minute drive time, or a 1, 3, 5 mile ring. The value of AI and these types of tools is that they can be data determined, data driven, right? The results can be a consequence of the data that you're looking at. So you can have a repeatable model, and the data sets itself will generate different outputs. And that's really important, because if you're analyzing a convenience store like a 7-Eleven, you want to use a different parameter than a Walmart or a McDonald's or a Starbucks. If you're analyzing self-storage versus office, you want different models. And so things like these self-adjusting classifications are really important. I can go through, generate the outputs. I can find just the clusters. And now what I want to do is do directional learning. So I want to find out how to enclose these, right? So these are the clusters. And so now, as a result, where are the most important ones that I want to use? I want to get rid of the 346 possibilities and identify the top 10 that I'm interested in. So we're going to use density analysis, right? And that will work all the way through hotspots and cold spots. And you can see this little purple one, and then these blue ones, which are cold area, right? And what it does is essentially target us into some very small locations, right? We've got the top 5 locations based on the mean sales volume being about 2,400. We're classifying based on the fact that if there's restaurants around it, it must be successful. We can look at the places based on this. Is it doing well? Is it underperforming against our estimate? Is it overperforming? Right? And that's what hotspot analysis does. And then in the end, we can cluster all of those, and then we can end up with this idea that we want to target a group of locations. So now this is my candidate list of places that I want to go and look at. Now you're probably looking at this and going, oh my God, there's 81 steps, 82 steps. How do I do this? Well, AI, as I've shown, will help you walk through all of this, right? It'll find the notebooks, it'll find the examples. You can go into ArcGIS Online, which is straight to your site to do business panel, click on notebooks, find the examples and work through them. And if you have technical people in your team, right? They can also take some of this code and apply it, right? Build those data sets. You've got a framework for working on. You can use the code that we create, the examples we create, and you can use the AI assistant to replicate those models. In this case, I'm using a population within 1 mile. I'm going to adjust the hospital buffers based on it. I'm going to pass it through some analysis, and I'm going to generate some results out of the back end. I can then add different forms of analysis. So go have a look, explore some of the things that are there. Different examples using different weighted models, but this is all what you do intuitively. AI and ArcGIS come together to help you build better analysis and reduce the time and effort that it takes to looking at thousands of restaurants, hundreds, in this case, 350 odd possible locations, down to the 5 that you might want to do. Random forest is one of the most powerful tools. We talked about this. It's a diagnostic tool, and you can adjust the quality, right? So you can say, what I want to do is train it to predict these different locations. I can get better and better in this diagnostic work, right, by giving new training data sets. So typically what you're going to do is you're going to identify the factors you think are important. You're going to train an algorithm to do that. And you're going to teach it and improve it, right? If one variable doesn't have a high correlation, you're going to get rid of it, right? And so it's what we call boosting. And in this example, I can say, well, in one tree, one example, to look at predicting the sales, I'm going to use age 65, a median household income. So if both the areas meet those criteria, then I'm going to look at healthcare provision. And random forest will automatically build these relationships. So you're not testing an intuitive model. It's going to create lots and lots of combinations of your intuitive model, and it's going to predict the sales based on that. And you're going to find the best model from all of your inputs, which create the relationship. And you can ask these tools to write it, right? To write code, to use random forest, to train it. And so this was the example, and this is the actual code that we wrote with these 15 factors. And then it predicts the most important of these. And in this case, I can come out and see what factors are the most deterministic. And then you can take that output and bring it back into tools like Business Analyst and say, now when I'm analyzing my sites, these are the 5 factors that I want to use. So maybe not median household income. Maybe that's not important. I learned that age is more important, and company healthcare. So this branch of the tree is more important than this branch of the tree. So things where I was intuitively saying, yes, these must be factors, I learned through AI that they weren't. And so to wrap up, what's next, right? You have an incredible set of learning and understanding from being CCMs. It's the power of the pin. And what really trying to show is that there's lots of tool sets and toolboxes that you can use to really start to turn your intuitive knowledge, your experience, the work you've done, the success you've had, into models. Those mental models you have, turn them into AI models. Think about how you assess the feasibility of a location, right? Start to throw away some of your assumptive ideas, right? Think about those most important factors and the influences, those independent variables, and maybe expand them, right? Maybe you downplay income and you upplay another factor, right? Like the different types of visits, or how competition might be good. I want to encourage you to explore different configurations to do this. You can build those models when you start thinking about your work. It's really good ways of just checking the assumptions and thinking, well, has the world changed? And there's some great questions in the Q&A that I'm going to have to deal with in a couple of minutes. And then part of this is you can train the models, right? You can retrain this. This might seem really hard to do, but our young guns, the young people we have, they're digital natives. They can pick this stuff up and they can run it. And you and they can work together and amplify your strengths, your knowledge, your experience, right? To create these training data sets. Essentially, what we're talking about is taking what you already do with exporting data to Excel or generating reports or infographics and using those to create a generative AI model that you can use repeatedly. You can use in different properties, you can use in different ways, different locations, and you can take all that knowledge and say, I have my model. This works. If it's wrong, go back and try it again. Try a new analysis technique, right? Go look at lasso regression. Go look at XGBoost, right? Go look at some of these different things. Ask the AI assistant to help you with much more deterministic results. Say, well, this doesn't work. What do you think? Right? Ask yourselves and your colleagues, the way you collaborate as CCAMs, about the knowledge, right? There's always room for improvement and there's always opportunity. So we all know this, and it's a bit of motherhood, but the outcome is only as good as the inputs, right? If your locations and your business relationships aren't successful, it's because of the effort and all the work that we put in. CCMs are uniquely positioned with technology, knowledge, training, education, and the network. And what we've tried to do at Esri is increasingly help you with the technology part of this. So I hope this has been useful, and got time for some questions. So Nikki.
Indeed. Excellent, Helen. Thank you so much. I think what you're showing is, so often, through history, right, we used, our minds to think smart, and then the introduction of data and tools to sort out those thoughts and understand, all right, well, what are some possible variables, or what is a faster way to get at all of those variables? And then now it's really, using the power of the newest computing technology to really help us think beyond what are we not thinking about, right? And to do that quickly and easily. So excellent presentation. So let's get to some of these questions. So we'll go top to bottom here.
Okay.
As they came in, right? So are there any pre-formatted queries in BARD for ArcGIS Python code industry-specific use cases? Talked about that early on.
There aren't some pre-formed queries, but those notebook examples that I showed and some of the code snippets, you can find them in ArcGIS in a number of different ways. You can go look at the Learn lessons. You can open ArcGIS online and go to the tab on the homepage. It will say notebooks. And then within notebooks, it will reference examples. So why don't I just bring that up again? So I'll just flick through this a minute. So if you go to the very top of the screen here, you'll on for map, then there's notebooks, and then click on those notebooks and it will open the examples. And you can scroll through and see them across multiple pages. So they're under Esri sample notebooks.
So that's right in Business Analyst.
Right in ArcGIS Online. Yep,
Mm-hmm.
right in ArcGIS Online.
Excellent.
And then the other thing we have, sorry, Nikki, just to
go ahead.
finish off on here, is there's a lot of really good documentation. Bard found this, ChatGPT finds this. So, you know, explaining like the random forest example, all you need to know in how to train a model, you know, the parameters you can put in, how you explore it, you know, there's wonderful documentation, pages and pages and pages of it. And there are some great training examples as well. And yeah, introduced to concepts like the bag of errors or bag errors. So
all great things to learn. Well, so let's talk a little bit about data. Just switch gears just a minute. So specific immigrant population centers is the topic. And this particular person's client is looking for ethnic grocery stores. And so for the data available in STDB, is there perhaps the data on ethnicity wasn't quite deep enough? Do you have some suggestions about that?
Yeah, so there's a couple of different data sets, and we've just added the detailed demographic and housing characteristics. And so for ethnicity, we typically recommend people use language spoken at home. We also provide through the Living Atlas information on country of origin. So that's probably the best source of ethnicity can implement or bring in from the census data. The other way to do this is that it's pretty easy to go to the census website. If there are some particular tables, tell us what you need. You know, we're here. You can find us. We'll share my email address. There are other of my colleagues online. You know, reach out to us and tell us exactly what you need and what you want. We think we've curated a great set of data. There's over 13,000 variables now for the US. But we're constantly here and learning and trying to expand and improve. So let us know.
Excellent. And we will make sure that the contact information gets shared along with the recording and such. I should have asked this in the previous question, but can you deconstruct the notebook for a minute and just talk about what is a notebook? As you showed, you know, where they are, where they can be found in ArcGIS Online, but overarchingly, what is it?
Okay, what is a notebook? So one of the best ways. So let's do it this way. We'll say, what is a Python notebook? Right. One of the best ways is go ask the question, right? And so a Python notebook is designed to be this interactive environment, and I'm not reading from this. You look in the window. So it's designed to be this interactive coding environment. So what you do is you start off and building a set of steps. Now I see there's a question about this is pretty hard for an older broker, right? But you know, a lot of this is about automation. So Python Notebook is really about creating an interactive environment that also allows you to automate. So it builds a visual coding environment, which is a document in which you type in instructions and you see the results. So think of it as write and execute. So it's like a diagnostic dashboard. So you putting a line of code and you see the results. You do a feature, you do an action, Now, why notebooks are really popular and important is as you go through those actions, you can learn through the previous steps, or you can go back and change the code. So let's say at step 12 of 20, and your subsequent set of steps, 13 through to 20, will change as a result of you doing edits to line 12. So it's a really great way of building models and repetitive activities. We use notebooks a lot for data ingestion, ETL, writing these advanced models. It's really the process behind building and training AI and machine models. So actually, oh, it says it in there. So it's a really wonderful capability that you can borrow these, right? Because they're exchangeable. So somebody writes a model, you can just open the notebook. You can actually email people the notebooks, right? And one of the ways that we're thinking about notebooks and these tools in our relationship with CSAM Institute is that we at Esri build these notebooks and provide you access to them. So they can run completely in the background. They can do these results. We build all the instructions. You type something in and you get the results of doing that. It's a really powerful way to automate work that doesn't require people to individually follow all those steps one by one.
I mean, and so it's really just learning kind of the basic constructs, and let's just say it's an any age activity. You know, and what we're doing is we're storing a repeatable process. So just getting to that point, and then it's perhaps simpler because it's all there in front of us and it's what we did the last time. Which brings the last question into play here, the last question on the list right now anyway. How many hours does it take one to get started and maybe get good so you can really harvest the results of that, you know, from the 3,000 possibilities, now we have 5, right? That's going to make these brokers, you know, really excited, right? And get their clients really excited to you know, these are those sites, and for these reasons, this is why it's awesome. So how long does it take somebody to get to that point?
It doesn't take that long. I mean, it sounds kind of counterintuitive. You know, you like part of it is really starting to learn the language. You know, you can ask a question like, what's the advantage of random forest over k-means, right? They're 2 words that you've heard me use here. And the thing about it is it will, through these types of generative AI tools, they will help you with that understanding, with that journey, right? So I didn't know I was going to ask this question. It's come back and summarized them, right? So one of the reasons why I chose to use random forest is this idea of overfitting. So what does that mean? Well, you need to understand it. That's going to take a while. You know, that's going to take you a time to understand the concept of overfitting. But generally what it's doing is it's saying, if I use k-means, I might overly constrain my data by being deterministic about the fact I want 5 clusters or 10 clusters, whatever that might be. Where random forest will allow you to not make a lot of assumptions and be presumptive about it. Yeah. So the thing about a lot of this is any of the techniques will help you move towards better data and better insight, right? And so in general, what it said here is that random forest is a more powerful and versatile algorithm, right? So yeah, I've learned that. It's told me that I'm going to concentrate my expertise, my learning, my focus onto k-means and forget the rest of it, because I want the best result, right? And so one of the great things about this learning and this work is you can use AI itself to focus on the things you need to do the specific work that you want. So in predicting sales, predicting viability, I'm going to forget that technique over there, k-means. I'm just going to focus on random forests.
I think everyone has learned so much on this. I would just want to take a quick, I want you to take a quick look through the questions, because I believe we only have one more, or time for one more question.
Okay.
And one that I like is there a specific AI button for adding queries? Easy button.
The easy button. Well, I don't want to do too much previewing, but around the middle of next year, we're actually going to have an assistant for business analysts that you'll be able to say, generate a report about Starbucks in Boston and show me the top 5 performing restaurants, right? And so our aim is to move that to say, of these 5 sites I've got in my area, which one would be best for a Starbucks, as an example. So we will be bringing out a AI assistant that's is working at the moment. We're going to continue to expand that and train it. So we are reaching out to the Site to Do Business CCM Tech leadership team about the sort of problems and needs and examples that you'll do as CCMs, because that's our training set. And people like myself, crazy heads, will build the models, we'll build the training sets, we'll teach the bots to do this through, deep learning and machine learning, and then that will create the artificial intelligence agent on top of it. But it'll be dedicated to the type of work we do in business analysts and the type of work that you do as CCMs.
Excellent.
So stick around for 2024.
I love it. Easy button all the way.
Easy button. Yeah, the easy button. So yeah.
So thank you. I'm really looking forward to that assistant and all the new data that comes in, and the great work that you guys are doing on your team. It's really outstanding. So thanks again for sharing your expertise with us on this webinar, and thanks to all of you who have joined us today for attending. And as a reminder, the recording will be available. We'll share the contact information as well, and it'll be emailed to all of the registered attendees. So we really look forward to seeing you again. Have a wonderful day.
Thanks, everyone. Bye.